This is Algebra 2, Lesson 22. I'm on page 107, homework problems are right here, starting with number 2. Alonzo ran toward Milano at 9 kilometers per hour. That's the rate. Alonzo was 9. He left at 8 a.m. At 8 a.m. At 10 a.m., Wilhelm began the same chase. So I bet we're going to do the rate of Wilhelm, but he doesn't leave to 2 hours later, right? From the same point. He caught him at 12 p.m. Okay, so their distances are the same. So the time of Wilhelm, he only traveled for 2 hours, but the time of Alonso was 2 more hours, so it's 4 hours. So we don't know the rate of Wilhelm. How fast did he run? So their distances are the same. So RATA is going to equal RWTW, and you're just going to solve for RW. And not equals 2 times 2. All right? All right, so that's problem 2, and you can solve it from there. Number 5. Huckleberries cost $5 a peck. So I multiply 5 times huckleberries. It's just like your dimes, quarters, nickels, all right? Whereas whortleberries cost $13 a peck. He spent $109. So for the total of those, he spent $109. That's my money. I don't have to eliminate decimals. Or 109 whatever dollars, yeah, for a total of 9 pecks. So H plus W equals 9. All right, those are your formulas. You can use, I'm going to use elimination. I'm going to multiply this by -5. So I have -5H minus 5W equals -45. I'll rewrite the first formula. And I have 7 whortles equals 64. That's 9. Nope, that's 8. 13 minus 5 is 8. So 64 divided by 8 is not 9. It's 7. It's 8. Hello. 8 whortles. I should have known that. If I have 8, then I have one of the H's. All right, that's number 5. Number 8. Divide. X cubed minus 4x. So it's x cubed minus 4x plus 2 divided by, it's x minus 1. All right, so I write the number that makes this equal to 0. I write my coefficients. There's my x cubed, there's my x squared, there's my x, and my constant. I bring down, I multiply, add, multiply, add, multiply, add, because I start with an x cubed. This is the coefficient for x squared. So it's x squared plus x minus 3, remainder of -1 over x minus 1. All right, number 10, 2 square root of 27. 2 square root of 27 minus 3 square root of 75. I ask myself, can I simplify any of the radicals? I can. 27 is 9 times 3. 9 is a perfect square. I can unsquare 9. The square root of 9 is 3. So that's 2 times 3. The 3 stays under the radical. Minus 3. 75 has a perfect square and it is a factor. It's 25. That's 25 times 3. When I unsquare or take the square root of 25, it becomes 5. So it's 3 times 5. The 3 stays under the radical. So I have 6 square root 3 minus 15. Square root of 3, I have like radicals, so I do 6 minus 5, so it's -9 square root 3. Number 11 is 3 square root of 2. 3 square root of 2 times 2 square root of 2. 2 square root of 2 minus square root of 6 times 4 square root of 3 plus 2. All right, we have to follow our order of operations. I'm going to begin by eliminating the parentheses, so I'm going to distribute to eliminate parentheses. So it's 3 times 2, which is 6. Square root of 2 times square root of 2 is 2, so that's multiplied. It's going to be 12. I multiply 3 square root of 2 times square root of 6, that just becomes 3 square root of 12 times 4 square root of 3. All right, so it's this whole term. Really, it's this whole term. There's 3 terms multiplied. This times this times this. Plus 2. All right. So we have to continue to think that. Like it's this times this value times that value. All right, so even though I distributed, this stays in parentheses and I now have to redistribute that. All right, this is going to be, I'm going to simplify this. It's 4 times 3. So it's going to be 12 minus, it's going to be 3 times 2 because the square root of 4 is 2. So that's going to be 6 square root of 3 times 4 square root of 3 plus 2. All right, I'm going to distribute this 4 square root of 3. So that becomes 48 square root of 3 minus 4 times 6 is 24. And square root of 3 times square root of 3 is 3 plus 2. So 24 times 3 is what? 1272. So that's 48 square root of 3 minus 72 plus 2. So it's going to be negative 70. Negative 70 plus 48 square root 3. All right, so understanding this operation, order of operations right here was important. It's this first term times what's in the parentheses times what is over here. All right, that's number 11, number 15. All right, we have 0.0035 times 10 to the negative 4th times 200 times 10 to the 6th divided by 700 times 10 to the 5th, and that's 1, 2, 3, 4 zeros. 0.12345 times, that's no times. All right, so we're going to first put them in proper scientific form, all right, notation. All right, so we move 1, 2, 3 to the right, which is negative. So it's going to be 3.5 times 10, negative 3, and negative 4 is negative 7. It's going to be 2. I move 2 to the left, which is positive. So it's 2.0 times 10 to the 6 plus 2, which is 8. Over, I move this one 2 to the left, which is positive. So that's 7.0 times 10 to the 5 plus 2, which is 7. And I'm moving this one 1, 2, 3, 4, 5. 5 to the right, which is negative. So it's 5.0 times 10 to the negative 5. So now I can look at my constants, multiply those, and then multiply my 10, my 10s with the exponents, times 10 to the power. All right, so this is going to be 3.5 times 2.0 divided by 7.0 times 5.0. And this is going to be times 10 to the negative 7th times 10 to the 8th over 10 to the 7th times 10 to the negative 5th. Move my camera down a little bit. All right, so this is going to be 7. All right, so this is going to be 3.5 times 2 is 7.0. And the denominator is going to be 35. All right, so we're going to do 7.0 divided by 35, and that's 0.2. All right, so this is going to be 0.2 times, the numerator is going to be 10 to the first power, because multiplication is addition, and the denominator is going to be 10 squared. All right, I'm going to resolve this in a minute. All right, so 0.2 times 10. Division is subtraction. It's 1 minus 2, which is negative 1. But I need to move this decimal place here for it to be in proper scientific form. So that's 1 to the right, which is negative. So final answer is 2.0 times 10. Negative 1 plus negative 1 is negative 2.